My project is the study of mechanical and electromechanical properties of semiconductor nanowires. Everywhere you have transistors, so everywhere it's made of semiconductor. They use what we call the top-down approach, where they go from a big bulk of silicon and they do, after a few hundred steps of chopping, coating, jiggling, like millions of times, they get these billion tiny identical pieces of transistors. But now we can't chop down anymore because we can't chop atoms in half anymore. We get to the point when it's just one layer of atom. So what I'm focusing now is the other way, the bottom-up approach, when you start with tiny little pieces, nanowires, and you arrange them in a clever way. I use germanium as a semiconductor instead of silicon. If you throw current through a germanium nanowire, it will go faster than if you do through a silicon nanowire. The problem is that semiconductors have an oxide around, which is not conductive. And the one in silicon is very controllable, very nice, very smooth. And the one in germanium is very bad. In industry, everybody's using silicon because you can control it better. And you can make nice, thin layers of oxide, which you couldn't with germanium. Let's say you have nanowire, and inside you have germanium, and around you have silicon, and you use silicon, the nice silicon oxide around that as well. So the current will still go through the germanium, then you would use the faster germanium property, but you will still have the oxide of the silicon around. So the best of the two worlds, pretty much. So if you could make like a finger size of these germanium nanowires, you could probably hold around 15 elephants on top of the finger. The nanowires, they have so few atoms across, they could bend and relax in different ways. If you try to bend a tree trunk, you're never going to get it. But if you bend a twig, that's fine, even though they're made of the same material. So it's just a matter of size. It's the same thing here. So we're trying to find different things that could happen if you chop things smaller. So you have the trench like that, pretty much, and a nanowire on top of the trench. And what I did here is I staple the nanowire on each side of the trench, just like a staple. And with my probe here, which is very fine at the end, I'm coming in and I go through it. And here you see the same nanowire, except it's broken here. But that cantilever moved while doing that. And by recording that motion, I know how flexible or strong nanowires were. It's hard to know if we have enough guidelines for ethics or environmental or health. But these guidelines should not be made by just ignorance and by, oh, we are afraid of something new. A lot of funding is being raised to study the impact of nanotechnology on the environment and health.